Hello all, in this video we are going to mainly concentrate on the energy promotion, that is tidal energy. So as we all know, tides are the rise and fall of sea levels caused by the combined effects of the gravitational forces that is exerted by the moon and the sun, as well as the rotation of the earth. So these forces create corresponding oceans or currents in the world's ocean, and due to strong attraction to the oceans, a bulge in the water level is created, causing a temporary increase in the sea level. So when the sea level is raised, water from the middle of the ocean is forced to move towards the shorelines, creating the tide. So this occurrence takes place in an unfailing manner due to the consistent pattern of the moon's orbits around the earth. So as it is evident from this diagram, as you can see, there is the possibility of both low tide as well as high tide based on the combined gravitational pull of the sun and the moon as well as the rotation of the earth. Now, tidal energy systems can extract either kinetic energy from the moving water of rivers, tides, and ocean currents, or it can be potential energy from the difference in height, or you also term it as head, between the high and low tides. The first method, that is generating energy from tidal currents, is becoming more popular. It is also known as OTEC, because people believe that it does not harm the environment as much as barrages or dams. Environment here means the aquatic ecosystem. Many coastal sites worldwide are being examined for their suitability to produce tidal energy. And like hydroelectricity, tidal power also produces no pollution, renewable source, because it is happening by events that happen in the solar system, and so will never run out. Tidal power is reliably predictable when you compare it with solar or wind, and it is a form of hydropower that converts the energy obtained from tides into useful forms, mainly electricity. And though it is not yet widely used, it does have potential for future electricity generation. And among the sources of renewable energy, it has traditionally suffered from relatively high cost and limited availability of sites with sufficiently high tidal ranges of low velocities, thus constricting its total availability. Now let's see the components of a tidal power plant, or TPP. So there are three important components of a tidal plant: barrage, which you also call as dam or dike, then sluice gates in the barrage for flow of water from the sea to the basin, and then a powerhouse equipped with turbines, each coupled to a generator along with auxiliary equipment. So please have a look at this diagram where the tidal basin is shown, and then a turbine channel as well as the turbine is shown, and the main part, the tidal barrage, and you can see the sluice gates on both the sides of the barrage. So the first one is showing an incoming tide. So you can see a head height is sufficiently high, and in the second diagram an outgoing tide is shown, and because of that the head height has gone low. So the first component, which is the barrage or dam. The barrage should be constructed by the material available at site or from a nearby place, and the barrages for tidal power projects have to withstand the force of sea waves, so that the design should be suitable to site conditions and the economic aspect of development. Rockfill dams or barrages are preferred because of their stability against the flow, and the barrage crest and slopes should be armored for protection against the waves. Sluices are the sluice gates. Okay, basically the vertical gates which are placed on the sides of the barrage. Tidal power plants operate on the continuously varying difference in level at which the basin must be filled with the sea or emptied to the sea as required by the operating regime of the power plant. This requires suitable sluice gates equipped with gates which can be operated weekly, and they are required to be operated 2 or more times a day. So there are two types: one is with crest gates and the other is submerged gates with venturi type. So crest gates are more prone to damage because of wave action and the masses that are carried by the flow, and the vertical lift gates are the natural choice, and they are usually made from stainless steel. And the last component, which is the turbines. The energy potential in tidal power plant is exploited from low to very low heads for which large-sized turbines are required. And if the water head is more than 8 meters, a propeller-type turbine is suitable because the angle of blades can be changed to obtain maximum efficiency while the water is falling. And the main aim of the designer of our TPP will be to achieve as long as a period of operation as possible. The turbines beginning and finishing work at the minimum head provide maximum efficiency, and this is the advantage of having turbines with variable pitch blades. And for low heads, generally, 3 types of turbines are used, and the selection is made according to the suitability. So the 3 types are bug turbine, tube turbine, and straight rolling type turbine. Moving on to the types of tidal power plants. Basically, they are classified into 4 categories: single basin single effect plant, single basin double effect plant, double basin with linked basin operation, and double basin with paired basin operation. So the first one, which is single basin single effect plant. So as you can see from the diagram, the tidal basin is shown, the sea is shown, you can see the barrage, and on one side you can see the sluice gates, and on other side you can see the power plant. So this is the oldest form of tidal power development and the basis of new tidal mills. A tidal power plant is simply a barrage across an estuary or creek whose principal elements are a powerhouse and a sluice. Estuary means the shore near to shore area. The basin is filled through a sluice by the rising tide, and the water level in the basin reaches the highest level of the tide. It provides the water head of tidal range to the turbine. The sluice gates is closed, and the turbine is started only when the water in the sea is at falling tide level. As the tide continues to fall, a hydraulic head is formed at the barrage, and at an appropriate time, water is released from the basin through the generating unit that is installed in the powerhouse, and the electric power generation continues until the head is reduced to the minimum turbine operating level. It normally occurs after the tide has reached its lowest point and has begun to rise again. At this stage, the turbine water passage is closed and all discharge from the basin is stopped. And now when the rising tide reaches the basin level, the filling sluice is opened and the refilling of the basin starts and the cycle is repeated. The cycle of operation showing the water level, the generating and the refilling period is depicted like in this figure. So as you can see, this cycle of operation offers different output characteristics depending on the time with respect to the tidal cycle at which the generation starts and stops. So if you observe the graph, you can see that you have the standing period as well as generation period, and in this graph the basin level is shown, and as you can see the generation period, for the more generation period you have the low tide level as well as the high tide level, and the standing period is a little bit longer in the case of a single basin single effect plant. So this will be this disadvantage compensated in the next type of plant. Before that, now we have been talking about rising tide, now we need to talk about falling tide. There are 3 variables which affect the power characteristics of the ebb tide. So for that I'll be introducing you to this term, that is what is ebb tide and what is flood tide. So basically, as you can see from the diagram, you have a high tide and low tide, and that is the tidal range. So ebb tide is the tide which is coming back to your, which is going back to your sea, and the flood tide is the tide which is coming into or outside the shore. So there are 3 variables which affect the power characteristics of ebb tide. So basically, turbine capacity, the minimum head under which the turbine will operate, and the time at which the generation starts and stops. So these variables have to be adjusted so that we get best results. And the general aim is to get long period of operation so that the turbines could commence and stop operating with the minimum head consistent with high efficiency. And in a single basin single effect plant, generation period is only 3.5 hours during every tide cycle. So the tide cycles per day, 2 tide cycles per day, the energy available will be intermittent and fluctuates from a maximum at spring tides to a minimum at waves. So let's see the single basin rising tide operation. So it is similar to the ebb tide operation, with the difference that power generation at the rising tide will be less than what is at the ebb tide would be. So in the rising tide, you have rapid filling of the basins. The turbine operates for a reduced period. And in the ebb tide operation, the turbine and generator operate for a longer time giving higher output. The single basin rising tide operation, besides its lower output, also suffers from intermittent and variable output. Let's move to the single basin double fixed plant. So as you can see, you have again a single basin and then the sea. The only difference in diagram is that the turbine is a reversible one. And you can see the diagram already shown and you can see that the standing period is so small in this. You have longer generating periods. Okay. This arrangement makes use of the combination of ebb tide and the flood tide working. The power is generated both during emptying and filling of the basin. With a single barrage, the waterhead which produces the energy operates from the sea towards the basin during the flood tide and from the basin towards the sea during the ebb tide. This is the most practical method of achieving this double tide operation using a reversible turbine so it can operate in both directions of flow. And in the operating cycle for double fixed operation, the curve shows the output is variable, but is lesser extent than in the case of a single basin plant. And the other advantages when you compare it with the single basin plant are the overall effect from the nuclear turbine capacity is greater by 15%, and this can increase if each plant is designed to the most economic type. And the period of operation is increased. The reversible turbines are going to cost a little more, and this additional cost is offset by the above two advantages mentioned. And the large period of operation is making it, you can use it for a predetermined period, or you can actually use it like when the demand is coming. And you have in France a power plant La Rance of 240 megawatt, which is using this type of operation, which is the single basin double fixed operation. Thank you.